So now we can do kind of a quick and simple example using the index of refraction. So suppose we have a light source, a sudden flash of light. And so the light goes traveling across, and some of the light goes through a material, a transparent block of material that has index of refraction 3.41. And so some of the light goes through there, some of the light goes past it. Now, if it's an air, index of refraction of air is approximately 1. It's really 1.000 something. But it's within the number of significant digits we normally do, we can just refer to it as 1. So what you would notice is that the light traveling beside the block reaches you a fraction of a second before the light traveling through the block. So I want to know what's that difference in time. So what we need to know is the length of the block. We'll say the block is 2.25 meters long. And so now I just want to know this difference in time. Well, we think about it, we say that's really not that hard, because the time is simply going to be, we know from physics 1, the time is going to be the distance over the velocity. And so that means that the time here, we'll call this 1 and call that one 2 going through the material. So T1 is just going to be the distance here that it travels divided by the speed of light. T2 is going to be the distance traveled divided by the speed of light in the material. Okay, so T1, that's going to be the distance over the speed of light. So that's just going to be 2.25 meters divided by 3 times 10 to the 8th meters per second. And so that's going to be equal to 7.5 times 10 to the minus 9 seconds. T2 is x divided by the speed of the light in the material. Well, the speed of the light in the material, we know, is the speed of light divided by the index of refraction of the material. So that's going to be nx over c. So that's going to be equal to 3.41 index of refraction of the material times 2.25 meters divided by 3 times 10 to the 8th meters per second. And so T2 is going to be equal to 2.56 times 10 to the minus 8 seconds. So delta T, that's going to be the difference here. So T2 minus T1, and so that turns out to be 1.81 times 10 to the minus 8 seconds. So that means the flash arrives 1.81 times 10 to the minus 8 seconds later. After the flash through the material arrives 1.81 times 10 to the minus 8 seconds later than the flash that passed beside the material. So this shows how light is slowing down going through the material.